All right, we're going to take a look at number 29 from 1.3. So we have a function f of x is x minus 4 over root x minus 2. And we're trying to find an extension of this function at the point x equals 4 that is continuous everywhere. So let's back up a step and talk about its discontinuity. And do that by saying, well, what is f of 4? If we look at f of 4, that would be 4 minus 4 over the square root of 4 minus 2, which would be 0 over, and then root 4 is 2, and 2 minus 2 is also 0. That's the indeterminate form. So we have seen this function in limits as well. So it's possible that this function came up as, like, say, limit as x approaches 4 of x minus 4 over the square root of x minus 2. And so there again, we don't have a direct substitution path. It basically becomes what we just did there. So the idea is to try to rewrite this function using some tools from algebra. So let's say that this were just a limit. That's usually how this question arises in context. So the limit as x goes to 4 of this function x minus 4 over the square root of x minus 2. What we want to do is take advantage of some of the concepts that we learned in Algebra 1 and Algebra 2 with radical expressions and conjugation. So we know that we can multiply by 1 and it doesn't change the value of the limit. And the value of 1 I'm going to choose is the conjugate of this radical x minus 2. I'm going to multiply by root x plus 2 over root x plus 2. That's the strategy. You're not really changing any value. You're multiplying by 1, but we're going to really exploit the idea that multiplying a radical expression by its conjugate eliminates the radical. So what happens now is we have a limit as x approaches 4 still of an x minus 4 times the square root of x plus 2 in the numerator. And then in the denominator, watch what happens. We have root x times root x, that's x. We have root x times 2, which is 2 root x. We have negative 2 times root x, which is negative 2 root x. And 2 root x minus 2 root x make 0, don't they? So then finally, we have negative 2 times positive 2, which is minus 4. And watch this. We have an x minus 4 in the numerator. We have an x minus 4 in the denominator now, and those factors cancel. After that cancellation, we're left with the limit as x approaches 4 of the square root of x plus 2, which can be done by direct substitution. That's just root 4 plus 2, or 2 plus 2, which is 4. So this strategy works whether the radical expression is in the denominator or the numerator. You want to multiply by a value of 1, but that value of 1 you pick is the conjugate of the radical expression over itself. So the extension of this function, finally the answer, I suppose, is y equals the function that we had left over there, root x plus 2. If the question is in a form of a limit, you just want to give the limit value. And that's number 29.